All right, welcome back. Today we're going to be talking about Unit 3 in the BJC curriculum. And Unit 3 is about, quote, data processing, which is a lot of what computers are used for, right? To process data, and lists. Lists are the basic data structure that Snap provides, and a list simply contains a first item, a second, a third, and a fourth, right? So it's a list of things that are in order, okay? And they're one of the classic data structures in computer science. So like in Computer Science 101, I guarantee you that we're going to teach about lists somewhere along the way. Okay? Now, lists kind of have a dual purpose. Okay? They can be used to store homogeneous data. That means that every data item looks like every other data item. So for example, I can have a list of numbers, a list of names, right? Or here, I have a list of the metric tons of CO2 per person for different countries. So the first element might be China, the second one the US, and so on, right? And it's just a list of metric tons of CO2 per person, okay? The list can also be used to hold heterogeneous data. So what do I mean by that? I just mean data where the items in the list are different, okay? So a classic example is that the first item is a name, the second item is an address, the third item is a phone number. When I think of that list as 3 elements, right? I can actually think of it kind of as a record, as a person record. I have, or a contact, a name, an address, and a phone number, right? There's my basic contact information. So that's another thing that lists can hold. So a list can either be used to build some kind of a record structure where I have different things about the same entity, the same person, right? Or it can be used to hold information about lots of things that are the same. Lots of contacts, right? Lots of countries, lots of whatevers. Okay. Now in Snap, what you have are lists. Lists. That's it. Okay. That's the only data structure. But actually, the other classic data structures in computer science, you can simply build using lists. And what are these other classic structures? Trees. Okay. Hash tables. Right. I'm not going to tell you what either of those are. Maybe you know. Maybe you don't. Doesn't matter. We'll get to that later. For now, lists. Okay. So let's see. Lab 1 is about contact lists, right? It's a Rolodex, for those of you who remember what a Rolodex looks like, okay? So that's what Lab 1 is. And what we're going to do is we're going to use lists to store different bits of data. What am I talking about? An actual contact, a card in the Rolodex, right? A name, an address, a phone number. Those are different kinds of data. And by the way, that kind of gives you the idea of abstract data types, which we talked about in Unit 2, right? And because I can actually build a little block, right, that I give it those 3 bits of information, a name, an address, and a phone number, and it creates the abstract type that holds those 3 pieces of information. Of course, you and I both know that that abstract type is actually a list, right? But we're hiding it inside this block. So you don't actually know what it looks like. You know whatever that block returns. When you phrase it like that, then you're actually talking in the language of like object-oriented systems, where those things are called classes and objects that are created. Or you might be talking in some structured programming languages, where those might be called a record type. Okay, I'm creating a record. That's what they correspond to in other languages. So right here you see that first big thing that says contact with name, and you give it a name, you give it a phone number, you give it an address, and it creates the record. The name for that is a constructor. It constructs the record. So in Java, you will have a constructor function. In C++, you have the constructor for every class. Here it is, right? That's part of the abstract data type. Now with the abstract data type, you're also going to have these guys, okay? And these are 3 little blocks that taking one of those records. Okay, they're just lists, but let's call them records, okay? And you ask, what is the name that's stored in this record? What is the address stored in this record? What is the phone number stored in this record? Again, that is a direct connection to object-oriented programming, okay? So even though that's not what we're, quote, teaching our students right now, we're teaching them Snap, we're teaching them computer science. Well, computer science is about ideas. They're getting the ideas of records and classes and so on, even if they don't know it, right? They're already being exposed to it. That transition, if they continue in computer science, they'll eventually want to program in Java or C++ or Python or something like that. That transition will be smooth because all the concepts are happening right here. Okay. Now, That's using lists to store heterogeneous data or to store records. Okay. The other thing we do it is just to store a whole bunch of the same things, the Rolodex, right? So I use lists to store each card is a record, and then I'm also using it to store a whole bunch of cards, right, as a list of card. Now, here is kind of an operation that you might think of. You have a Rolodex, right? I actually need to call Sally right now. So how do I find Sally's card in the Rolodex? That is an operation. Find the card, right, that has this property. That's a nice abstract operation for a list. Okay. So here we have find context with name. That's specialized for this application, but you can see that find is actually very general, right? It feels like a general operation that could apply to all lists. So I call it an abstract operation. Now, here comes another one of those huge moments. Remember back in Unit 2, we talked about keep, right? Keep all the elements of a list that pass some test. Right? I want all the even numbers in this list and so on, right? That was one of the classic, one of the big three operations on lists. Here's the second one. It's called map. Okay? So here's what map does. It's actually pretty simple. What map does is it kind of creates a new list that is the result of applying some kind of operation or function to each element of the other list. For instance, let's say that we have a list that has the numbers 1, 2, 3, 4, up to 10. That's my favorite list. Okay? And now I want to say, I want to double each element on the list. Okay? Now, I want to be careful. I don't mean double each element on the list. There is no way to tell the number 1, I want you to be 2 now. Okay? That's not what I'm doing. I'm not changing the numbers. I'm creating a new list, right? A new list of the exact same length. 1 through 10, 10 elements. This new list is going to have 10 elements. The first element is twice the first element of the original list. 2 times 1 is 2. The second element is twice the second element of the original list. 2 times 2, that's 4, and so on. I'll get 2, 4, 6, 8, all the way up to 20. That's what happens when I map the operation 2 times to the list 1 through 10. Okay. By the way, if I take this same idea, map 2 times, but now my list is 1 to 100, then I get 2, 4, 6, 8, all the way out to 200. Right? Map is a very abstract operation. Okay? Just simply returns the result of applying some operation to each element of a list. Some operation. Look here. Okay? I'll start with 3 times. Right? Beautiful. Let's just multiply by 3. Right? Notice that there's a blank. This is one of those blocks, right, that has a blank. Better name for those? Functions. Right? Here's another one. Letter 1 of. That selects the first letter from a word, right? How about join blank s? That will simply take whatever you give it, put an s at the end of it, and return that, right? So cat turns into cats. Dog turns into dogs. Bird turns into birds. And you can see that that is exactly what the map function returns. Here's the value that it returns. And you see that it's a list of 3 elements because I gave it a list of 3 elements: cat, dog, bird, cats, dogs, birds. That's how map works. That's it. That's all there is to map. That is the second major list operation. Keep, map. Okay? All right, lab 2. We're not going to play tic-tac-toe. Okay, we're not actually going to play the game. We're going to write some code around the game. Okay? So what we're going to do is we're going to use lists to store some of the data that we could have, like where are the X's and O's on the board. Okay? A couple of different ways of storing that. One way is to have a list of lists. The first row is X, O, blank. The second row is blank, blank, X, and so on, right? 3 rows. The way they chose to do it, and programmers actually get to choose how they do things, right? It's one of the great things about programming. They chose to store it as a list of 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just what they picked, okay? So that's a list. What is actually on the board right now? Here's another useful list. I want to see a victory formation. Okay, so a simple victory formation, the first row is all the same. That first row is 1, 2, 3. That's a victory formation. Another one might be 4, 5, 6, 7, 8, 9. Or it could be a diagonal, right? 1, 5, 9. That's a list of positions. That is, if all of these are of the same, then that person won. Okay? And another kind of list could be a list of winning positions. right? So a particular winning might be 1, 2, 3. But there's lots of ways to win. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 4, 7, etc. Right? So you can have a list of all the possible ways to win. So let me show you this right here. Here's the board. Notice 1, 2, 3, 4, 5, 6. That is actually, that green line there tells me that I'm thinking of that as a way of winning the game. Look over here, list 4, 5, 6, right? That's how I represent that. Just a list of those 3 places that if you're there, you won. And then this gives me a list of all those ways of winning. 1, 2, 3, 2, 5, 8, etc. Right? All of the ways of winning. Those are just all of the lists. So this particular exercise, all it does, quote, all it does is exercise working on lists. So your students get lots of experience doing list operations. Okay. All right, let's look at Lab 4. Lab 4 is super cool. Okay. Lab 4 is about building data visualization tools. So what am I talking about here? I have some data, lots of observations I've made, like say the temperature on many different consecutive days. How do I store that data? Okay, you know the answer is a list, right? So I'm going to put the data in a list. That's what's going to happen. I want to be able to see this data, right? You know, if you actually take the list of numbers and you give it to a human being, they'll look at them and go, yeah, that looks like temperature data, thank you, right? If you want them to be able to use that data, the best thing you can do is give them a graph, right? Then look at it and go, ooh, look, it looks like it's getting warmer, okay? So that's what we want to do. We write programs that take in some data and create a picture that represents that data, okay? Your students do not have to have AP statistics by the time they come into this thing, okay? So we're going to have to tell them the kinds of graphs that we want them to generate, right? They do not the word descriptive analysis or anything like that, but they don't have to, right? We're simply going to ask them to draw a bar graph or a histogram, okay? We'll have to tell them what they look like, right? And then tell them how to draw the lines and so on, and off they go, right? Scatter plots, line graph, horizontal, you know, all this kind of stuff. They're, quote, easy to code, which means they'll take a day or two. But you know, the output, the result is actually pretty exciting, right? Because you get this data that at first you have no idea what it is. And part of the lab is there's this block that when you ask it for the data, it gives it to you just as a list, right? So they don't have to collect anything, right? They just get a bunch of numbers to start with, and then they're asked to draw pictures. This is actually a pretty exciting lab, and a lot of them just love this kind of stuff. Okay, so what did we learn? Again, I want to look at the, quote, real computer science concepts that were in this unit, okay? So the first thing that I want to make sure that you really remember that you saw here is about objects, records, instances. These are the kind of the basic things in object-oriented programming, okay? So in object-oriented programming, we create objects. An object could stand for a person, could stand for a car, could stand for, well, it could stand for any real-world entity. It's a noun, okay? It can also be like an abstract noun. Okay, so it's very powerful. In databases, we call them entities, right? In Snap, we store them as lists because list is all we got, okay? But it actually lets us do the same kind of stuff, encapsulated as an abstract data type, okay? Now, we did a lot of working with lists. In particularly, we saw lists as an abstraction for a collection of things, okay? So remember I said that the College Board does not accept a variable as an abstraction. Right? It accepts a list as an abstraction. So for instance, if you write code that draws polygons by getting a list and then joining those points in lines, that is considered abstraction, right? Because you have abstracted your idea of polygons into vertices, okay? So I don't recommend using that. There's more obvious abstractions, like a block that you create, okay? That's what I tell my students to say, this is my abstraction. But it would pass muster. Okay. We talked about visualizing lists. I kind of consider that fun as opposed to deep computer science concept, right? But you know, you gotta have some fun along the way. So I'm gonna count it. Okay. And then we also met our second great abstraction or abstract list operation. We knew about keep. That was the first one, right? Keep all the elements that satisfy this test. Now we met map. Map all the elements in this list by applying this function to them and give me the result, right? Map is one of the great abstract list operations, and we just met it in Unit 3. Okay, of course, we also have some kind of discussion labs. This unit actually starts something new in that it's not just discussion, but it's also a little bit of research. Hey guys, I want you to go find out something about this and come back, Okay, what are we trying to teach them? We're trying to teach them how to conduct research so that they can do the explore task later. Okay, so one of the topics is artificial intelligence. What is it? What can we do right now? What is the state of the art? What does it mean? And of course, there's some obvious things to bring into discussion. Jobs, we're going to lose all our jobs. Oh my God, we no longer have to learn another language because it can translate for us, right? There are some obvious implications. And then there are some deeper implications, right? So let's talk about that. For example, there's learned bias, right? What do I mean? Let's say that I am an HR person and I'm screening job applicants. This is a white guy, yep. Black, no. White, yes. White, yes. Black, no, right? I would get fired, right? I'd probably get thrown in jail. It's just a bias. It is something that is explicitly illegal, right? But now let's suppose that we train a machine so that it learns to do the filtering for us. So we don't have to look at 10,000 applicants. We just get the 10 that matter, right? And that machine is learning from people. How should I select applicants? And the people that it learns from just happen to be biased. Well, now a machine is doing it. A machine doesn't have any preconceptions. A machine doesn't have any biases, right? So if it says that these are the 10 people I should look at, those are the 10 people I should look at. Surprise, right? The machine is actually learned to reject the black applicants, right? And so that's no good, right? That's actually possible. That has actually happened. My favorite side story on that is the chatbot that Microsoft released. And within a day of kind of learning from Twitter as to how to respond to things, it became a really rude and racist and misogynist chatbot, and they had to take it offline. It's like, I'm sorry, we made a mistake. Maybe we shouldn't have had it learned from Twitter. Okay, so that's the real world, right? That's something that needs to be addressed when we throw these AIs into the real world. Okay, they also see things like robots. I mean, that's robots and AI, right? So how do robots work? Helping us with manufacturing, helping us with this and that. Again, that's something that they can learn about, they can research, they can bring back to the classroom and discuss. There's a bonus here. We actually have 2 of these labs in this unit. We have another one on, quote, big data. Now this makes sense because we did data as a collection stored in a list. We did visualization on it. So why not talk about big data, which is when you have so many elements. I mean, hundreds of thousands, millions, tens of millions of data points. Okay. Again, we want to engage them in conversation. We want them to learn to research, to think about what they're learning so that they can do a really good job on the explore task. Okay. The discussion that they have in this little lab is about visualization and understanding large data sets. Okay. So they're not actually asked to build anything, right? We asked them earlier to help us visualize some data that had 10 data points. Now we're asking them to use existing tools to visualize data that consists of hundreds of points, right? Well, we're making the jump. We're not asking them to code up and scale up their code to help us. So yeah, they're going to actually use these tools and make some conclusions about big data that they can share with the rest of the students. They're also going to learn about metadata. What's metadata? That's data about the data. So for example, I have a camera. I go off and I take a picture of a beautiful sunset, and I get the picture, right? That's in the file. That's in the image file is the picture that I took. But also stored in there is what time did I take it. Also stored in there is maybe, okay, depends on the camera, but it may store things like where did I take it? If it has a GPS and it can say, oh, this is where I was. You might actually know in which direction you were taking the picture at. Okay, you might actually know what settings my filters, my lenses, and so on were at the camera itself, so that I can, if I ever want to go back and try to take another picture like that, I can see, oh, this is how I did that, right? All of that information is in there, whether you want it to or not, right? So if you have like hardcore evidence that I was not at that location, because look, here I am in this picture, right? They can actually go in there and look at the metadata and go, excuse me, this picture was taken the week before. So no, that's not an alibi, right? So that is metadata. That's something the students should learn about. The AP exam has lots of questions about metadata. They love this stuff, right? So it's good for the students to actually learn about it and just at least for once go through the exercise of figuring out what can people do with the metadata that I'm not aware of, right? So that's what this little lab is all about. All right, I'll see you when we talk about Unit 4.